Alright, so today we've got more DirectX 11. And what I want to do specifically is to draw some text. Oh god. So we've got two rectangles. Yes. We've got two rectangles. Two rectangles with alpha blending and with texturing. So to draw text, we just need to load a font into that texture and then put it on the rectangles. Alright. So the first thing to do would be to go find the texture and to remove the data, the initial data. Yeah, so the data is going to come from, well actually, no, we do need the initial data, because we're not, oh, this is rectangles. No, that's not it, that's not it, that's not it. I'm looking for the texture. Where did I create the texture? Here. Yeah, there's the pixels. Yeah, that's fine. Why can't I close the... Oh. I bound the wrong key to the wrong thing. Okay, hold on. Keyboard shortcuts. Focus into primary sidebar. Let's bind this to something else. Control H. Now, remove key binding. I gotta think about what to bind that to. Okay. So this data, so this, yeah, we don't really need to write to that. We just create it once. What we do need to write to is the rects, which we can already do because it's writable. I just don't have that hooked up to the main part of the application. Okay, well, let's just have one of these rects. So that's the color. That's the dimensions. Well, I mean, we could have both, whatever, it doesn't really matter. That's the dimensions. Oh, and the dimensions correspond to the texture dimension, that's right. Okay, well, let's load a font into that. I will do the easy mode of text rendering, which is just a bitmap font. That's 7 hours ago. What was this? Include shell if you... Yeah, well... Font... Yeah, this font. Actually, can I create a new file like here? New file. No, I can. UN64 was it unsigned long. Taking from here. UI font. Global font data. Okay, that's, well, that is the font. And I guess we can just use it here. I mean, might as well. Import font like that. Does that work? Yeah. And instead of these fake pixels, we'll just have real pixels. Of course, we kind of need to know what the dimensions are. And I believe the dimensions of this thing are just, yeah, it's a byte, so each byte is a row, and if the bit is set, then that corresponds to the pixel being like fully on, and if the bit is not set, then the pixel is fully off. And it's like 1, 2, 3, 4, 5, 6, 7, 8. So that's a byte, that's another byte. And we've got 16, I believe there's 16 of these per character, and it's just the next character after that. Okay. So global font data. Yeah. So we can iterate through the characters. And how many characters are there? I think it's 127 or something. Well, we'll find out. For char, well, byte, let's say byte, from 0 to whatever it is, 127. I mean, we know there are 255 bytes. So it's, well, there are 255 64-bit entries. And if there are 16 bytes per character, well, there are 16 bytes per character, that means that there's half of that, right? So 16 bytes per character times the, and this is 255 times 64 bits, it's 8 bytes. Yeah, so 2 of these correspond to a character. Yeah, so it is then half. It's 128. Well, 256 of these, so 128 sets of 2, so 128. There. So there are 128 characters. And what we want to fill in, yeah, actually what we want to fill in is just the texture, right? So the texture, but our texture is gonna have, like, we need to expand each bit into a byte. Essentially, decompress this thing. Yeah, so the first two is just a white. Oh, we can unset, yeah. Alright. So I'm gonna expand that out. Okay, into a proper texture. So we need pixels, byte, something, pixels. I guess we can just keep it on the stack. It's actually big enough to hold this texture, it's not that big. And we're gonna have, what, like, I don't know, whatever. Char count is 128, and then long bytes, like char width is gonna be 8. And then long char height is 16. Char count, char width, char height. Yeah. So then, so if we just go over all of these, so this would be check count. So if we go over all of these, there's our character. We can get the corresponding bytes for that character from this font texture. So they're just one after another. I believe that is it. So that's like the first byte, and this is just the second byte. Oh, the second 64-bit. Entry anyway. So we want to reinterpret this probably as just a byte pointer. Or even just a byte array. Byte array, char bytes. So from here, actually, how is this gonna work? From here to char times 2 plus 1, right? It's this array, but we want to like cast it essentially. We want to cast it as a byte array. Although I'm not sure how that's gonna work. Okay, well, first of all, let's see if that compiles. Linker error. Okay. Okay, well, what's bytes? Length 8. Well, the fact that length is 8 is promising, somewhat. The last one's not included. It's +2 actually. pointer is here, and then we step by the appropriate amount, presumably by 16. Yeah, okay. Okay, finally we get somewhere. Okay, and the length of this is 16, so there are 16 of these things. Okay, so this works as expected. For bytes, like is that correct syntax? No. For each? Yeah. Now we just go through those bytes. Okay, so the byte represents a row. So, well, we need somewhere to write this into. Okay, so we have count. It's 8 wide and 16 deep. So it's count times width times height. So we need that many of those. I think that works. For each byte. Well, now we just go for, I mean, it's essentially offset, right? Well, offset 0, offset less than 8, offset, which is another loop. Mask is 1, shifted off by offset. If byte and mask, it's bitwise and, then the corresponding alpha needs to be filled. Alpha, some index, is 1, like that. Well, not 1, it's 255. Okay, what's the index? Alpha index is does index come first, or does oh my god, what is with the scaling here? For each index comes first. Okay, well that is the index. Okay, so byte index is just the row index, essentially. So we need to, we're just gonna have them next to each other. Well, I mean, it does have to be a rectangular texture though. Okay, so what's the alpha index? Well, it's the character index, which is so it's the character index times character width, because it's going to be 8 wide and they're going to be next to each other. So it's character index times character width. So that's the first row, plus byte index times, and this is going to be the whole texture width. Alpha texture pitch. Well, I guess just alpha pitch. Okay, what's alpha pitch? Well, alpha pitch is character count times character width. Okay. Yeah, this goes here. Oh yeah, this is not... I mean, they are constant, so... Yeah, you can. Yeah, you can. I mean... No, this has to be a byte. Why do we not have byte literals in D? Like, what's that all about? No, just trust me, this is fine. Like, the fact that this doesn't work is just horrible. Like, it's so bad. Just have a byte lit, like, you know this fits. You know this fits, just make it fit. Okay, yeah, I don't really know what this is gonna do though, necessarily. So let's step in here and see. Okay, well, oh my god, that is a lot of stuff. Count height, well, we know what that is. Alpha... Okay, well, there's the character. It's 1. Well, hold on, let's step here. There's the character, it's 0. There's the bytes for the character. Can you do this like binary? Can you show me the binary for the representation of this thing? Yes. It's all zeros, so not very interesting, this one. Okay, so this next one though, that is something. I mean, you can kind of see the outline of something here. Character, that's the bytes. Byte index is 2, so it's that one. Okay. Well, there is bounds checking at least, so if we got this wrong, then presumably it will tell us. Alpha index is that. Well, let's see. No, this is out of bounds. How come? What's minus 128? Bytes assigned, I see. Okay, well, we don't crash this time. Now we need to upload the texture. Upload the texture to the GPU and see what it looks like. Presumably help us debug it. So this is alpha width is check count times char width, alpha pitch is alpha width, alpha height is character height. Size is alpha pitch times alpha height. So that's the total size of texture. Does that compile? Yeah. Alright. Width of the texture is alpha width. Height is alpha height. All this other stuff doesn't change. This goes away. This is alpha pointer, and pitch is alpha pitch. It's the initial data. There's the texture. Okay, so this is, if this works, it's gonna look really strange. Yeah, it looks really weird. Now let's actually look at what the texture is. Like, whatever about the actual rectangles. Let's see the texture. We can do that here. Okay, inputs. Oh, alright, so the texture is completely messed up. Completely messed up, but getting somewhere, at least. Yeah, I don't really know how this happened. Exactly. But what are the, so at least the dimensions seem to make sense. Yeah, it's like we're not stepping, like we're not filling that first row, or first column. We're not stepping correctly, something like that. Okay, so character times width plus byte index. Okay, so this doesn't seem correct actually. So character times width gets us to that first pixel. Gets us to the first pixel, so like to here, let's say. But then we need to step by oh yeah, we need to step by this offset. We need to step by the offset. And then we need to step, so that's offset. And then we need to step to the correct row, which is byte index times alpha pitch. Okay, let's launch. Okay. I'm interested in the inputs. Ah, there we go. Well, this is looking like something. I mean, it's wrong. It's weirdly skewed, but the characters are the correct characters. It's italics. We got italics for free. Okay, why are they skewed like that? And why don't they go all the way down? Well, this byte index shouldn't be here. I hate this program so much. Yeah, there we go. We have a font. Seemingly we have a font. Now I just need to supply the correct dimensions for the rectangles. Okay, so this rect buffer, so we're not going to be supplying any initial data. And instead, oh yeah, how big do we want it to be? Well, we're gonna need to store length and capacity. So this is, well, it's not rects, it's ES input size of times rects, not rects, times, well, yeah, rects capacity, so this needs to be set to something. Yeah. Well, cast to uint and rect buffer is actually it's rects buffer. Okay, we should not see any triangles or any rectangles. Yeah. Well, now we just have a way to add a rectangle, and that's it, right? So to add a rectangle, okay, well, we're gonna have to, like, what's in there? Top left, bottom right, texture top left, texture bottom right, and color. I mean, I guess we can just ask for all of this. let's just say, well, rect. Well, we can't just send it like. We don't want to map and unmap CPU, like GPU buffers every time. CPU buffer. Rect length is data. Rect length plus equals 1. So there is bounds checking. Actually, there isn't. Well, I mean, we can make it so there is. Yeah, if we just make this an array, where the length is the capacity, then there will be just bounds checking there automatically. So this is the actual GPU buffer. CPU. I mean, I guess we could map and unmap every time. And then we wouldn't have to duplicate them. Actually, I could just map it, right? And only unmap before drawing it, and then just map it again, so that you can just write to it. Mapped. Yeah, just keep this around. Then whenever we create this rect buffer, just map it immediately. How do you map the mapping again? Map. Except can we actually do that? Like, it will discard the previous contents. Well, actually that's fine. If you only map it at the beginning of a frame and unmap at the end, then we can discard previous contents just fine. So this mapped would be rect mapped. We're not writing anything, we're not unmapping either. And what are we mapping? We're mapping rect buffer. Write discard previous contents. Okay. So we map it at creation. Mapped. Oh god, it's like mapped p data or something. Well, you don't need to cast it. Except this is a PS input. Then we do buffer rect length equals data, and we write to it. And and rect's length plus 1. So to get rid of this, we're gonna have to unmap it first. Oh, it's the rect's buffer. It's rect's buffer. So you don't, okay, so this mapped thing, you only use it for writing, you don't use it for mapping. So you unmap it, then you release it. So that compiles. Okay, so when we draw things, how many instances do we draw? This is 4 vertices per instance, and this is the number of instances. But before we can do that, we need to unmap it. So we unmap, actually before setting the vertex buffer, yeah, even before, yeah, right here, we need to unmap it right here, then we set it, and then at some point after this we need to map it again, somewhere, maybe after drawing. Maybe like right here, we can do rect length is 0, and then context LPV table map. And then what's the 0 right discard 0 rects mapped. Set length to 0, so draw, set length to 0 and map again. Something like that. So we shouldn't see anything because we're not pushing any rects, but we also don't get any errors. Yeah. So now we can push some rects in here from, not from anywhere, but I suppose from here. Like somewhere in the loop, in the main loop, like before drawing the thing. Alright, what do we need? top left, bottom right, text top left, text bottom right, color. Well, let's say 0, 0, 0, 0, top left, bottom right, 100, 100, text top left, 0, 0, bottom right, 8, 16, let's say, color. Can we not pass a literal really? Can struct literals are just not a thing. It's awful. Ah, well, that struct is inside of the... I guess all of this is going out. So that's 0, 0. Instead of being 0, 16. Wait, 0, 16. Bottom right. That should be like 8, 16. Let's go to like the end of the texture, which is 8 times 128, well, 127 to be at the beginning. Because it's each character is 8 wide, and we got that many of them. Actually, is this 828? Okay, I'm not seeing any rects. Well, let's see what happens there. Okay, why? Why? Well, this should be 0, right? Length plus 1, yeah. Well, then we step in here. Whatever about this. So there it is, we unmap it. We set the buffer. Then we draw instance where there's one instance. Set map again. Okay, well, that seems fine. Okay, so we're passing in the appropriate stuff here. Wait, hold on, texture. There's another place. There's a texture dimensions, right? So somewhere there's a text dim. Ah, yeah, right here. And yeah, we don't really need to store this because it's gonna be a constant size anyway. So let's do this after. I mean, it's clearly involved, like here. Store it here, right? And the dimensions are alpha width and alpha height. Okay. Yeah, so that seems like it's doing the thing. Now if we match the dimensions, so if we draw it like 16, well, width is gonna be 8 times 128, and height is gonna be 16. Yeah, so that seems correct. Actually, while we're here, I might as well look at the... so like this one is 1023, so it is 1024, yeah. Yeah, I mean, that's fine. We have some text. Of course, we want we don't really want the whole texture. We don't want to specify it like manually like this. Yeah, we want to have like a void glyph. Tell me what character to draw, and we'll just push that in. Of course, we do need the position on screen, top left, but we only need top left. Which, I mean, I guess it does kind of mean that we need to store this. At least some of that. Yeah, we don't need to store the actual alpha, but we need to store some of this information. Well, let's see, what do we actually need? Rect, well, vs input. Rect, top left, then it's top left plus character width, so like font share width, top left plus character width, well, top left X, top left Y plus font character height, so that's bottom right. Okay, well, there's top left, bottom right, then it's texture top left, texture bottom right, and now it's color. I should probably rename this to like push rect. This is push glyph. so what's the texture top left? Well, it's character times character width, right? So that's the x, and the y is 0. Text top left, and then it's text top left x plus font character width. Text top left y plus font character height. Yeah, it looks like we just need character width and height. And color. Is that all we need? Yeah, so this is font. Yeah, it looks like we don't need to store anything else, just character width and color. Oh, well, we also need texture dimensions, which, I mean, I guess we can rename this to, like, font, something, font, text dim. Oh, just, oh god, put that inside here. And then we don't need the font. Struct font. No, well, we still kind of need this though. Just to know how big it is. So there's the texture dimension. This one though. Const buffer for dimensions. So we can put the const buffer for dimensions here and also width and height. Those are just integers. Font. And we need to actually set the appropriate things here. Font char width is char width. Font char height is char height. Does this still work? Yes. Push glyph. Well, I mean, we can still leave this rec D3D11. Push glyph A and top left is. Can we pass a literal? 1, 1. Let's see, is that not allowed? Really? But that, like, it's just structs are unusable as functional parameters if you can just pass a literal. I mean, I guess you can do this. And that'll kind of work. Okay, let's do that. Yeah. Okay, so looks like we can draw. I mean, we can look at the texture and then run the doc. We don't really need that. Okay, well, there it is. I suppose the only thing we're missing is like push text line. Well, we're also unsupplying a color here. Actually, default function parameters, I think it exist here. Maybe? No? Is it like that? I don't know. Oh yeah. They do exist. It's just you have to repeat color like 4 times. I see. So now we can specify a color. One, 0, 0, 1. So the only thing I'm missing here then is void push text line. Well, it's the same kind of default color idea. For each, well, text, I mean, it's like line. Push, glyph, character, top left, color. Push text line. No, well, we're not advancing. V2. Current top left is top left. X. Okay, so to actually pass it. And then it works. Alright. Okay, so if we can draw text. Now, I want to look at the texture. So, in addition to glyphs, we want to also be able to draw just solid rectangles, which we can't really do right now because everything refers to the texture. But if we take this 0 slot and just fill it, just do a solid fill. Where's our texture here? Actually, it needs to happen here. I mean, it's almost like just for each. Well, it's, I mean, no, it's for. What are we looking for? Bytes, byte, right? It's like not index. And we know, well, I know we are referring to the alpha. We're referring to the alpha. Well, really, we don't even need that. We just need the mem set. Memset, alpha, pointer, and just however many bytes there are in that first character. Well, actually no, because it's a two-dimensional. No, so we do need to iterate over the rows. Memset row to 255. Actually, is it gonna set each byte? I don't even know if it's gonna. You know what? Let's not do that. Let's just do a double for loop. For row, column, long index is row times alpha pitch plus column. Alpha index is 255. I think that's all we need. That'll set the first. Fill the first character to be used for solid rects. Let's see, did it fill the first character? this we can use for solid rectangles now. And push rect. Okay, so we can just do a push solid rect. V2 top left, V2 bottom right. Oh, that could be dimensions as well. V2 dimensions. And color. And really what happens is this, except text top left is gonna just be 0. Text bottom right is going to be, well, it doesn't really even matter. I mean, we could make it like chair width, chair height, but yeah, doesn't really matter. 0, 0. Color, top left. And really what I want to write is top left plus dim, right? But yeah, so that's not gonna work very well. Font. Can we just overload an operator? Let's see. D1 tour. Do we have operator overloading anywhere here? Operator overloading. Yes, is this gonna be like the spec? Okay, well, do I just define a member function called op binary? Yeah, you do. It looks of it. Where's our v2 here? Okay, so v2 op binary, but not just any op binary. It's two part two, like a string op plus. Oh my god, plus v2 right hand side. Okay, so v2 result is x plus RHS x, y plus RHS y. Return result. Does that work? Seemingly so. Can we step into that? No? No? I see how it is. It just kind of works on its own. Plus dim. So like here, oh yeah, we're not calling push solid rect. Maybe we can step into it. push solid rect. Top left is 100, 100. Okay, it should be like V2. V2 dimensions. Well, whatever. And color. That's color. Okay, so if I F11 this, yeah, we do step into it, I see. Hopefully this isn't modified. And that is our rectangle. We should make sure we can color it. We can color it, alright. Is it gonna blend? Yes. Yeah, it does. So we have transparency there as well. Okay. Well, we can draw text. We can draw solid rectangles. I think that's pretty much sufficient to draw whatever kind of 2D UI we want. Like everything here, for example, is just either a solid rectangle or it's some kind of glyph. Well, there's icons as well. Don't really need those for now. Yes, like we can draw all of this just with that rendering pipeline, except for these glyphs and these special characters. Alright. Well, that's gonna be enough for now. See you later.